So let's look at a couple more examples using substitution. I'll do a couple more here. So here I have the definite integral from 0 to 1 of 1 over 2x plus 4 dx. So let's see, I'm going to pick u equal to 2x plus 4. Now I'm going to pick du then, du derivative of 2x plus 4, that'll be 2 dx. So right here's u. This piece right here then, well, I only have the dx, I don't have the 2 right here, so I need to get rid of that. We'll multiply both sides by 1/2. So 1/2 du equals dx. The 2's will cancel over here. So I'm going to take this piece out, replace it with 1/2 du. So let's see, I'll factor the 1/2 out first. This is the integral, let's see, of 1 over u du. I'm going to take these limits of integration and rewrite them here. So let me change my color to do that. So I'm going to be using this expression. So let's start with our upper limit of integration. When x is equal to 1, u is equal to 2 times 1 plus 4. This is 2 plus 4. U is equal to 6. So since 1 was my upper limit of integration originally, that means that u equals 6 will be my new upper limit of integration. Next, I'll take my lower limit of integration, 0. X equals 0. U is equal to 2 times 0 plus 4. This is really u equals 0 plus 4, which gives me 4. So since 0 was my lower limit of integration, that means that 4 is my new lower limit of integration. And what this means now is that I'm just essentially almost starting this problem over. I'm saying, hey, I'd really like to evaluate this definite integral. So let's see. When we do that, we'll have 1/2. This is natural log absolute value of u, evaluated at 6 and 4. And remember, because these are in terms of u already, I do not need to take that 2x plus 4 and plug that back in. We can just go ahead and say this is 1/2 natural log absolute value of 6 minus 1/2 natural log absolute value of 4. Maybe we'll just get, you know what, I'm going to get rid of the absolute values here since 6 and 4 are already positive numbers. There's no reason that we need them. I'd probably leave my answer like this. But of course, you could get a decimal approximation. Just type that into your graphing calculator. Let's look at one more example before we wrap this video up. Here I have the definite integral from -10 to 25. I have e to the negative 0.01x dx. So again, I need a u. So let's see, u. Hopefully we see this exponential. We say, oh, that's got to be the power. U is equal to negative 0.01x. So du, the derivative, is negative 0.01 dx. So I say, okay, this power right here, that's my u. So this piece right here, I'll underline it. This is my u. All I have is this dx left. So that means all I want in this expression is dx. I'd really like to get rid of that negative 0.01. So you could divide by negative 0.01 if you'd like. Probably the easier way to write that, if you take 1 divided by negative 0.01, you actually end up with negative 100. So I'm just going to multiply both sides by negative 100. It'll just look a little bit nicer. So I end up with negative 100 du equals, over here these two are going to cancel, just dx. So this piece right here, this is negative 100 du. So let's perform our substitution. The negative 100 is a constant multiple, so we can bring that out front right away. times the integral. I should have e to the u du. So I performed my substitution. I now need to rewrite my limits of integration. So we'll take those off to the side over here. So these are x values. Let's start with our upper limit of integration, 25. When x equals 25, u is equal to, and again I'm looking at this equation right here, u equals negative 0.01 times x. So negative 0.01 times 25. I should end up with negative 0.25. So negative 0.25, that is my upper limit of integration. When x equals negative 10, u is equal to negative 0.01 times negative 10. Here I should end up with a positive 0.1. So that means my lower limit of integration was 0.1. So this is my new definite integral that I'm trying to evaluate here. So okay, negative 100 is a constant multiple. We're not going to worry about it. The antiderivative of e to the u du, that's just e to the u, evaluated at negative 0.25 and positive 0.1. Notice here again that the upper and lower limit of integration don't necessarily follow that pattern of the upper limit of integration being greater than the lower limit of integration. Don't try and fix it. Don't overthink it. Just leave it as it is. And then I need to just plug these values in. So I should have negative 100 e to the negative 0.25 minus negative 100 e to the 0.1 power. Minus a negative, of course, plus a positive, and then you could go and get a decimal approximation there if you'd like, but that is our solution. So be careful when you're working with integration by substitution and definite integrals. Make sure that you're changing the limits of integration if that's the method that you choose to use, or that you take, in this case, we would be taking negative 0.01x and plugging that back in after we found our antiderivative. You're doing one or the other of those two. You are not doing both.